All right, we are still on Chapter 1. Chapter 1 functions more or less as a review of everything. I know there was a review chapter that came before this. We should be done with this chapter by the time we're ready for the test this week. There's probably about 3 more sections left. And a lot of this is going to be a review for you guys still, and that's all right. This section's on multiplying and dividing real numbers. So we're just looking at real numbers here, and if you remember a few lessons ago, the classifications of numbers that should make this a little bit easier for you to know where we're going with this. So starting with multiplying, okay? I skipped a few slides in here because they were completely unnecessary. So when you're multiplying real numbers, the product of two numbers with the same sign is going to be a positive number. So what that's going to look like is if you have, if you have like 2 and 4, that's going to be, and they're both positive, your solution is going to be positive. So you have 2 and 4, your solution is going to be a positive 8. If you have -2 and a -4, your solution is still going to be a positive 8. And probably the best way that I can describe that to you guys right now is if you think about it this way. If you have two negatives, so you have a -2 here and you have a -4 here, okay? When you make a negative sign, you're making a line, right? So the way you can look at it is if you have two negatives, it takes 2 lines to make a positive. It takes 2 negative signs. It takes 2 negative signs to get to this positive right here, okay, when it comes to multiplication and also with the division. So we start off by explaining that it's just product of 2 numbers, but what you're going to see in addition to this is it's really the product of any even number of multiples. So if you have -2 times -4 times -1 times another -2, that's going to be a positive. Okay, that's still going to be positive because these two will be a positive, and these two will be a positive. That's going to give you a positive. So the other way that you can look at this is if you look at it as the product of an even number of multiples. Okay, so long as those signs remain the same. All right, and again, what this is looking at down here is you're looking at the product of 2 numbers with different signs is going to be a negative. So this was just dealing with products with the same sign. Products with different sign is going to be a negative. So if you have a -1 times a +4, that's going to be a -4. All right, and the same principle as what we used up here actually kind of implies. So you're going to have 1 negative, 1 positive. That's going to turn your answer into a negative solution as well. All right, and that should be very much review for you. Hopefully this is nothing new quite yet. Hopefully, if it is, we have plenty of time to make up ground, so that's not a problem. So product of 2 numbers, the same sign, is going to be positive, whether it's 2 negatives or 2 positives. Product of 2 numbers with different signs is going to be a negative number. All right. So here's some examples for you to work on with that. So if you have a -3 and a +8, you should be looking for a negative solution for the same reason that I just explained. All right, you have two negatives here. Two negatives is going to be a positive. 5 times 2 is going to be a positive 10. All right, we're going to talk about the product of 0. Whenever you have a 0 in multiplication, it's always going to be 0 no matter what the sign is. You have a positive 10 and a negative 5. Your solution is going to be a negative, which will be a negative 50 in this situation. Okay, fractions, same deal with fractions, all right? And you guys remember, you multiply straight across with fractions. So 5 times 1 on the top is going to be 5. 6 times 4 on the bottom is going to be 24. It's negative 5 6 times a positive 1 4. So you're going to get a negative solution. And the same principle applies with your decimals as well. All right, products involving 0. Anytime you have 0 in multiplication, your solution is always going to be 0. All right, so this is a rule that you should really write down. Okay, so multiply 5 times 0 times negative 3. You have the 0 in there, you can automatically put 0 as your answer. Whenever there's a 0, anytime there's a 0 with any kind of multiplication, doesn't matter what any of the other numbers are, your solution is going to be 0. And this one, you have a negative 1 times a negative 6 times a negative 7. All right. Negative 1 times negative 6 times negative 7. I explained this one to you a little bit. So you're going to have, you have an odd number of multiples. All right. So because you have an odd number of multiples, your solution is going to be a negative number. Okay. Because these two would give you a positive, but then you would have this 1, which would come down, which is a negative. So your solution is going to be a negative answer, right? You have a negative 1 here, so you don't have to worry about multiplying the absolute value because 1 times any number is going to be that number. So this one's really just looking at if you're paying attention to those signs, all right? So 6 times 7, you guys know, is 42. Because you have an odd number of the same sign, you're going to have, like I said, over here, the positive comes out of these two, positive here times negative, you're going to get a negative solution. So a negative 42 is going to be your answer. All right, and some more examples for you. Shouldn't be that much to look at. I want to bring your attention down to this bottom one, okay? Because this one is an even number of multiples, where the last one was an odd number, this is an even number, okay? So you have a negative 3 times a negative 4 times a negative 5 times a negative 1. Okay, these two are going to give you a positive, all right? It's going to be a positive 12. These two, because of the signs, are going to give you a positive. It's going to be a positive 5, okay? So your solution is going to be a positive 60, okay? So because you have the even number of signs, it's going to be a positive value. All right, exponents. Your exponents are really just multiplication, right? This concept was introduced, I believe, during the review for you guys as a brief reminder. So anytime you have an exponent, what you're really doing with an exponent is you're dealing with how many times you're multiplying that number by itself. That's what an exponent is. It's saying, all right, how many times am I multiplying whatever the base is by itself? So you have a negative 2 to the 4th power, okay? Negative 2 to the 4th power. All right. Now, I wasn't using the parentheses on the other one, so you're probably going, why is she using the parentheses on this one? Why does it matter now? Because of what the base is, all right? So we talked about how if this is your general setup for an exponent, this right here is your base with this as your exponent. Okay. Now, the reason why the parentheses matter, the parentheses really matter with an exponent, is the parentheses tell you what the base is. So in this situation, your base is this entire set of parentheses, okay? Which means you're doing a -2 times a -2 times a -2 times a -2. Positive, because you have an even number of negative signs, it's going to be positive 16, all right? And that matters, okay? Having those parentheses there matters, all right? So here's another example of the same situation, all right? But there's no parentheses here, okay? The lack of parentheses in this situation matters as well. All right, so you have -8 squared. All right, so what's the base? What's your base? Is it going to be a -8 or is it going to be a +8? Well, up here we had parentheses. Okay, and with your parentheses, your base was anything inside the parentheses. Without the parentheses, your base is only what's right in front of your exponent. So because there are no parentheses, what's right in front of your exponent is just the 8. Okay, so your base is going to be 8. So you deal with this like this. You can look at it this way with a negative on the outside. Okay, so 8 squared equals 64. All right, order of operations, now you deal with the negative on the outside, so it's going to be a -64. Okay, and that's because the base in this situation is a +8, not a -8. All right, that's probably going to be the most common mistake that you guys will be making. So I'm just going to keep saying that. If you don't have parentheses, your base is the number right in front of the exponent, which in this case is going to be your +8. Okay, and then you factor in that negative sign afterwards. All right, reciprocals. This is review for you guys as well. All right, two numbers whose product is 1 are called reciprocals. All right, what that looks like in a practical situation. All right, you have two numbers whose product is 1. So let's take 2 times 1/2. All right, it's the same thing. Saying 2/1 times 1/2. You multiply straight across. You get 2/2. If you have the same number on the top and bottom of a fraction, your solution is going to be 1. All right. You're never really going to see this anywhere. You might see it in several years in calculus, but most normal people are going to call this a reciprocal, not a multiplicative inverse. All right, quotients involving 0. All right, you cannot have a reciprocal of 0. All right, cannot have a reciprocal of 0. And that is because 0 is unique. And we will talk about that in just a couple of minutes. Okay, so the reciprocal of each number. 55, the reciprocal of 55 is 1/55. The reciprocal of -3/7 is going to be a -7/3. Okay, so what you're doing is you're looking at these and going, all right, where is the 1 in this situation? All right, so in the situation of 55, another way you can write 55 is 55/1, right? So what you're doing with that to get the reciprocal is you're just going to flip that. So the reciprocal of 55 is 1/55. Okay. So when you're dealing with the -3/7, same deal. You flip it. The 7 goes on top, 3 goes on the bottom, and it's going to become a negative solution. Dividing real numbers. All right, this one is important. If a and b are real numbers and b is not 0, then a divided by b is the same as a over b, which is the same as a times 1/b. Okay, That sounds kind of confusing. It looks like a mouthful, but I need you guys to just hang with me. It makes more sense than it appears that it should. So if you think about it this way, if you have 2 divided by 4, okay, 2 divided by 4 is the same thing saying 2 over 4, which is also the same thing as saying 2 times 1/4. Okay, and if you really want to go really far with this, it's the same thing as saying this. All right, all of these are the exact same problem, all of these. And why that's important is when you're dealing with fractions, and this is something that the advanced math class had to deal with, is if you have, this won't make much sense to you guys, and that's okay. If you have something like this, this looks intimidating, right? This looks intimidating, but it's the same thing as putting a divided by sign over here. So it looks really confusing to have all kinds of ridiculous fractions happening in the same situation, but what this rule does is it allows you to get rid of some of those crazy fractions to make it look more normal, and something that you're a little bit more used to. That's the advantage of that. So I want you guys to keep track of this. If it helps to have an example with numbers instead of letters, make sure you write that, because you're going to be seeing this all through the rest of algebra. And if you struggle with remembering this, you're gonna find yourself getting really confused and trying to figure out things that really shouldn't be that much of a challenge. But because you forgot, this basic rule right here, you might get yourself into trouble a little bit later. The quotient of 2 numbers with the same sign is a positive number. This is the same as the rule of multiplication, all right? The quotient of 2 numbers with different signs is going to be a negative number, okay? So you have 2 signs that are the same here, 2 signs that are the same here. It's going to be positive in both situations. Negative here, positive here, it's going to be a negative. Positive here, it's going to be a negative. So the same rules apply in most situations in multiplication and division. So if you have an even number, of the same sign, it's going to be positive. If you have an odd number of the same sign, it's going to be a negative. Okay, so it's the same rules. The dividing real numbers, the rules with the signs are exactly the same as the rules in multiplication. All right. So your first example, 42 divided by -7, your solution is going to be negative because you have 2 different signs. All right, it's going to be a -6. -16 divided by -2, 2 of the same sign, so it's going to be a +8. -80 divided by 10, 2 different signs, it's going to be a negative solution, it's going to be a -8. All right. Fractions, dividing fractions. Hopefully this is review for you guys, but when you're dividing fractions, and they kind of do this for you, but they obviously don't explain why they do it. You are taking, because of that reciprocal rule that we looked at before, you're taking this second one right here, and you're going to flip it. All right, and then you're going to multiply by that flipped reciprocal. Okay, and now you can just multiply straight across, just like you can with normal fractions. And always make sure, yes, this is the right solution, and what MathExcel will tell you when you type this in is it's equivalent to the correct answer, but it's not the correct answer, all right? So you need to make sure that you actually reduce these, okay? Same thing down here. All right, except you have 2 of the same sign, which means you're going to have a positive solution. You flip the second one, you multiply straight across. All right, division involving 0. Write these rules down. Okay, write these rules down. You will see them again. You will keep seeing them, and you will save yourself a lot of time and effort if you remember them, because it will make your life so much easier to not have to do all of the work involved in some algebra problems when you see a 0 in either the top or the bottom. All right, so if you have 0 over any number, that solution is going to be 0, right? 0 over any number, the solution is going to be 0. Any number over 0, your solution is undefined. Okay, any number over 0, your solution is undefined. 0 over any number, your solution is 0. And this will come back actually in graphing, which is several chapters from now, but this will come back when you're dealing with the slope of lines and graphing. And because somebody always asks, what happens with this? If you have 0 over 0, is it 0 or is it undefined? Okay, this is one of those math situations that like the math world kind of explodes a little bit when you do stuff like this. All right, but the best way I can explain it is your undefined is always going to trump your 0. All right, so if you have 0 over 0, your answer is going to be undefined. And I guess the best way to explain that is undefined is kind of like saying like this number doesn't even exist. This isn't even a possibility. 0 just says it's a possibility, but the answer is 0. So if you had to think about it in some kind of crazy example, you know, 0 on the top says, you know, we don't have any horses. There are 0 horses out of this many horses. What 0 on the bottom says is more like flying horses that also have a horn on their head, so like a Pegasus unicorn, they don't exist. Okay, so this right here, this is like your Bigfoot, your Pegasus unicorn, your mermaid. That's what x over 0 is. The 0 in the denominator. It's a non-existent thing. Okay, 0 over a number, you just don't have any. So they exist. So this is your normal horse, but you just don't have any. This is, guys, that's not even a real thing. All right. Now, if you want to know why this exists in math, go talk to Mr. Schofield. There are really amusing things that happen in physics with undefined solutions. If you really want to know, or you can just wait several years until you have him for one of your classes. So just remember, 0 over a number is 0. A number over 0 is undefined. And it will make your life so much easier to remember this one, because then you don't have to do all the work of finding out, well, what's this number on the top actually mean? It doesn't matter. There's a 0 on the bottom. Same deal with this. Okay? This one's just telling you it doesn't matter where you put the negative sign. You can put it on the bottom, you can put it on the top, you can put it in front. Doesn't matter. It's the same thing. It's all the same thing. All right. So divide these numbers. 0 over negative 7. That's going to be 0. Okay. It's going to be a 0. 8 over 0. It's going to be undefined. Okay. It's going to be undefined. All right, evaluating expressions. Everybody's favorite thing, all right? This is taking everything that we just covered and putting it into, practical math. What you're actually going to see as homework questions, or what you'll have as example problems when you'll actually be using this in an algebra class. That's what you're seeing with this. All right, so you need to always use the order of operations. All right, the order of operations don't disappear just because we're not talking about it anymore. All right, so you have 7 times a negative 9 plus 2 times a negative 6. All right, order of operations, you do your multiplication first. So 7 times 9 is going to be 63. It's a negative and a positive, so it's going to be a negative answer. 2 times 6 is going to be 12. All right, negative times a positive is going to be negative. All right, and then what we looked at the end of last week is you have 2 negatives. All right, so you add the value together and you just put a negative sign in front of it. So you're going to add the absolute value of these numbers. Okay, add the absolute value, which is going to be a 75. And then you're going to put that sign in the front. All right, so your solution for this is going to be a negative 75. All right, so, oh goodness, what about fractions? We have a fraction thing. We have numbers on the top and numbers on the bottom. What do we do? All right, same deal. All right, remember I told you consider when you see a fraction bar, treat that as a pairing symbol. All right, so think of it this way: negative 8 minus 3 times the negative 2. All right. So you see how I put the large parentheses around the entire thing on the top and on the bottom? That's a way of reminding yourself you got to do just the top first or just the bottom first, and then combine the solutions that you get. All right. So negative 3 times a negative 2 is going to be a positive 6. All right. So that's what you get on the top. Negative 2 times negative 3, still a positive 6. And what you get on the bottom. All right, 8 is 14. Negative 9 plus 6 is going to be a negative 3. All right. Can this be reduced? Does 3 go into 14? No. All right, so this is going to be your solution to this problem. All right. Evaluate the expressions for the given values that they provide. All right. So you have x equals a negative 5, and you have y equals 8. All right. When they want you to evaluate an expression, we looked at that already. They just want you to put those values in. All right. And always represent your variable with a parenthesis. Okay, before you put that number in. All right, so your x is going to be a negative 5. Your y is going to be a positive 8. All right, and you can multiply these across. But remember, you have a positive, a negative, and a positive, so your sign, your solution is going to be a negative value, right? So you work that all the way through. And one too far. Okay. Work that all the way through. Like I said, you have a negative sign for your solution. Okay. Negative 42 times 8 is going to be negative 336. All right, same deal. This one walks you through it. So you have x equals negative 1, y equals negative 5. You put the parentheses in the place of the variables. You plug the value inside the parenthesis. 3 times a negative 5 is going to be a negative 15. 45 times 1 is 45 with a negative 1. So negative 15 over negative 45. You have 2 negatives. That's going to be a positive solution. You can reduce this. So reduce it to 1/3. Right? Y squared minus y cubed. Right? This is why I tell you to use parentheses to represent your numbers. All right? To represent your variables before you plug it in. Okay? So this is your x. You represent it with the parentheses. This is your y. You represent it with the parentheses. The numbers go inside that. If you don't do this, you're going to get a different answer, right? Because 1 squared or 5 cubed is different than negative 5 cubed. Okay, so that matters. So negative times a negative is going to be positive 1. Okay, you have an odd number of the 5s. Okay, so it's going to be a negative 125. All right. Negative and a negative, that's going to become positive. So 1 plus 125 equals a 126. All right, so always replace, if you have to plug in something for x or y, always replace it in your work with the parentheses so that you know, especially with the exponents, what you're applying that exponent to. If you don't do that, you'll get the wrong answer. All right, is this a solution to this problem? All right, all this question is telling you to do is it's telling you to plug in the value that they are asking. Is this a solution? They want you to plug that in to the original equation and see if it turns out to be the right answer. Okay, so you have negative 16 over x plus 7 equals 9. All right, they want to know if negative 8 is a solution to that problem. All right, so you have negative and a negative, that's going to be a positive. 16 divided by 8 is 2, plus 7 equals 9. 7 plus 2 is 9. 9 equals 9. So your answer to this one would be yes. Yes, this is a solution to this problem. Okay. Applications. When they say applications, they're just trying to make you not think they're giving you word problems. They're giving you word problems. All right. The trick with word problems is to realize that not all of the words matter. So what you should really do with word problems is, if it's on paper, box it out. Box out any number. See what matters. All right. In this situation, your keywords that you're looking for, you're going to look for anything with a number and anything with an implied number value. Okay. So when you have the phrase lost $400, okay, lost $400, that can imply a negative 400, right? So in an ideal situation, you would just box that out, all right, on each of 7 consecutive days in a stock market. All right, so you have 7 days. Represent his total loss as a product of signed numbers and find his total loss. Okay, so finding the product, you have 7 days, $400 each day. Okay, this guy hopefully is not making his career in the stock market. So you have a negative $2,800 that he lost in that total 7 days in his stock market trading. All right. So that is the lesson for tonight. This is multiplication and division. Pretty much the same thing. So go into Math Excel, find the examples, get the examples done, and then make sure you have the notes done for this. There are some things in here that you might have wanted or might need to have some review on or some examples for, and make sure you have that done. And I will see you in class tomorrow, and we will work on some of those problems tomorrow in class.